Here's triangle 9. We have a right triangle. Right triangle's got to be right there in the corner. Across from the right angle is always the hypotenuse. So we know this 13 is our hypotenuse. So we're given that. Now, adjacent and opposite sides depend on where the angle's given. In this case, the angle's given here at 22. So across from it is going to be our opposite side. And right here down helping form it with the hypotenuse is my adjacent, the side that's sitting right here where the 22 is closest to. So this is adjacent, across from it's the opposite. Now, we're trying to find, obviously, the adjacent side, and the measurement that we're given as far as length is the hypotenuse. So I need one of those trig functions that deals with adjacent and hypotenuse. Well, which one is it? Let's remember. Some old hippie caught another hippie tripping on acid. Again, acid, we don't do drugs, stupid idea, always. So, we have adjacent hypotenuse. Which of those deals with adjacent hypotenuse? That appears to be the cosine. So we're going to use the cosine function. So I have the cosine of the angle, always the angle, which in this case is 22 degrees. Always put it over 1, equals. Now, it's got to be adjacent on top. The adjacent divided by hypotenuse. You can't flip them. A comes first, so I put the adjacent piece first. Who is the adjacent? That's my unknown. That's my x. So I put x right here, divided by always the hypotenuse on the bottom of it. In this case, I have 13 as a measurement. I now have a proportion, so I do the means extremes. X times 1 is x. That'll equal 13 times the cosine of 22 degrees. I grab out my calculator and make sure it's in degree mode. And I do 13 times the cosine of 22 degrees. Put that in parentheses to just be careful, because if you have the 13 on the other side, it's going to do cosine of 22 times 13. It's going to do the cosine of that big number. You don't want that. If you put it in parentheses, you're never going to have trouble no matter where you have this 13. So we do 13 times cosine of 22. When I did it earlier, I got approximately 12.05 as my measurement. So, in this case, that makes sense. The hypotenuse is bigger at 13. This was a small angle. That's pretty big across from that. So this is going to, it could get pretty close to that hypotenuse. Looks like sort of a 5, 12, 13. But anyway, this guy right here is 12.05 for triangle number 9.